welcome to the Association for Vertical Farming AVFami session. So who of you here today is into urban and vertical farming because of its positive impact on society? Just raise your hand. So there's people who are not in here for that. Anyway, you have come to the right place because you will go through the Amification process, which will help you develop a mindset to look at urban and vertical farming in a different way, in a bigger scope, and will help you make your farm or make your urban farming activities even more sustainable. That's our goal. So what is the Amification process? First, you get a knowledge and wisdom infusion by Megan and me. We're going to tell you about why AMI, how AMI, what AMI, and we're going to do that with 3 AVFami cases. And at the end, we're going to tell you still about the challenges, because it's never easy. It's never easy. Well, it's simple, but it's never easy. Afterwards, in like 30-40 minutes from now, it's your turn. You will have to start brainstorming and thinking about the ecosystem way mindset we're going to help you with. And afterwards, we're going to do the Aquaponics bowl, kind of like fish bowl, where you will be presenting what you have brainstormed, and we will have a big group discussion. And after that, you will be completely amified. And that is a good thing. You will know that. That's a very good thing. So, we are here in New York, and it's a very cool place to be in New York because it's here where vertical farming really got popularized with the skyscraper, vertical farms, and the vision by Dixon Despommier. It's also why I got into the scene, and many people many years ago got into the scene because of that, of the skyscraper, vertical farm, and vision of sustainability. But I want to ask you all, you know, it's been 6-7 years ago when the futuristic skyscraper vertical farm started. Who of you still believes it's possible? Futuristic skyscraper vertical farms. You think? Andrew is there. Who doesn't believe it? You don't believe it? Okay, that's good. That's good. Well, with AVFami, we started around the idea about 3 things. We want to make skyscraper vertical farms happen because they're cool. The second one, we want to use them as a driver for ecosystems in cities, or cities as part of ecosystems of this planet. And the third one, we want to make vertical farms more profitable. So bringing those 3 together is really what is AMI about. It's not so easy. So, but before we want to tell you how to be AMIfied, we need to understand also why we need to turn our cities into ecosystems and change the way of food is produced. I assume most of you already know that. Who doesn't know? Why? No? Okay, good. So I'm going to go fast through the next ones. This, my friends, is the biggest problem our planet has faced since 65 million years, since the dinosaurs died out. This is the most ecologically devastating thing our planet has undergone, and it's our linear economy. You can also say global warming is the biggest problem. This is actually, global warming is a part of this linear economic mindset. We mine fossil fuels, we burn them, and we throw them in the air, polluting the air, changing the whole ecosystem of the planet. So this is really a picture that shows the whole problem. And also food production is a part of that problem. We have monocultures, industrial monocultures, where we kind of kill all biodiversity and just put one crop. We destroy an ecosystem. Because we destroy an ecosystem, we need to fertilize the fields, we need to put pesticides, we need to mine mountains to make it happen, destroy another ecosystem. And because there's no ecosystem to catch all the fertilizer you put on the field, you kind of get another ecosystem destroyed, the aquatic one. And just because we want to produce some fucking food, it doesn't make that much sense. And by the way, we produce food and we kill another food source. So this is not the way we should go. Oh, has any of you seen Interstellar, by the way? Like, that future, if we keep on doing it that way, our planet's going to die out. I don't believe we're going to get there. That's not going to be our future because there's a huge global change. If we've seen the movie screening yesterday, it's about tomorrow, there's a big global change happening, a big transition, and we are all part of it. So I want to thank you all for that, for being part of it. So good job. And AMI is also part of it and tries to make a true change. So if we want to transition from that linear economy, where do we transition to? we kind of have to learn from the master in ecosystem thinking, and that is nature. When we think about fertilizer, I like to use the example of phosphate. Phosphor is the building block of life, so you kind of need it to live. Every organism needs it to live, and it's mined as phosphate. We mine 160 million tons of phosphate a year to fertilize our fields. Around 30 million of that gets washed away in aquatic ecosystems, so that's a lot. But nature doesn't do it that way. It just slowly erodes from the mountain, and one phosphate molecule gets used 1 million different times all over again. And the big difference is we mine 1 million molecules of phosphate to use only once. Nature uses one molecule of phosphate 1 million times. So there's kind of a learning process we need to go through, and that's what AMI is also about. The first step is we need to learn from nature. The second is we need to find our place in nature. But I'm also here to bring you a positive message. You know, we are also always hear the message of we need to lower our carbon footprint, we need to eat less meat, we need to eat less that, we need to lower our luxury. And I think that's not a very good message. Does anybody like that message? You know, you need to tone down or whatever you do. You better not be alive because it's bad for the planet. Nobody likes that, right? I don't like that too. But that's why I like to use the example of a good friend of mine, a colleague from urban farming Ghent in Belgium. And he's like the Dixon Despommier of permaculture in Belgium. So he's like a big visionary doing all these things. And a couple of years ago he told me, Zjef, we need to increase our ecological footprint. I'm like, well, we need to increase our ecological footprint? What does that even mean? He said, you know, we humans are a kind of useful species. We are a useful species. So if we team up with life, we can create more biodiversity. We can change the cycle. We're in a spiral, a downward spiral, destroying the ecosystem at the moment, but we can change it around and become like a spiral of creation, of biodiversity and beauty, and that has a lot of implications. I'm going to tell you a little more. And that is where AMI comes from. AMI, aquaponics, mushrooms, insects, sees controlled environment agriculture as a part of ecosystem thinking. We see every controlled environment as a small cell in a human body. Like, you know the inputs and the outputs, and every cell has a big important function in the body, and the body has to thrive. So if you start your urban or vertical farm, you kind of have to think as of an important part of society. You need to find its function, it's the reason why it's there. You have to find a problem, solve a solution, be like that. So that's the Amification process you're going through right now. How does it feel? You feeling good about it? Okay. And when you think about vertical farms or controlled environments as food-producing parts of ecosystems, these skyscraper vertical farms become possible because they can become places where nature, humans thrive into. You can live in them, you can work in them, you can just be around them. Skyscraper vertical farms become easily possible, and it has more implications even. Because if we can create ecosystems, strong and beautiful ecosystems, we can just go to other planets. Colonizing Mars, no problem anymore. And that's also one of the reasons why a couple of people from the AMI team, 3 of them are actually involved with the European Space Agency on trying to create ecological systems. One of them is even on our payroll, Radu, on the ESA payroll, so that's pretty cool. We're looking for some NASA people, by the way, when we're in the US. Anybody involved with NASA? Not yet? Soon. After the Amification process, you will be. So, this idea, this whole way of thinking, this is a bit very vague and very... So, with the AVFami team, we kind of thought 1.5 years ago, how will we make this happen for controlled environment? Which organisms are interesting? How will we do it? And we looked at nature and saw at least four organisms that's interesting when it comes to food producing. The first one is our animals, obviously, plants, obviously, but I think, and many of us think, the most underestimated organisms that are not nearly enough seen in our society are mushrooms and insects. Because their purpose in nature is as upcycling of organic matter. So a plant dies, a fungus goes on it, or an insect goes on it, and repurposes that organic matter. And that is why this is an important part of the AMI mindset, is to turn that, to use that ecological aspect of ecosystems, use it for vertical farming. And what's even more interesting about mushrooms and insects is that they use much less light. Insects don't need light, mushrooms overall not. Some of them like a little bit light, so the energy costs are way down. So that makes, for vertical farming skyscrapers, even more interesting. Now, like I told you 1.5 years ago, we started with the idea, with the concept, and we knew close to nothing about it. We knew close to nothing about mushrooms, insects. Megan was not yet there to help us with the fish, but we got there. The first thing so we did was like bringing together the facts about this mushroom industry, about the insects industry. How does it work? What does it need, mushrooms and insects? So we worked to the AVF Summit, a couple of months to the AVF Summit, to bring up the big idea of the AMI idea, to bring it in full force. So we worked for 4 months. On the left side you can see our AVFami banners we made. We made infographics on each system, how does it work, what's the input, what's the output. And using those banners you could kind of already connect the dots, but Megan's going to tell you more about connecting the dots, very important. And we did even more than that. After that, we made the infographics. We also did a 2-hour AMI session. We invited industry experts from the insect industry, from the mushroom industry, and from the aquaponics industry, put them on stage, made them give presentations, and put them in a panel. You can see all the presentations and the panel discussions online on Vertical Farming Academy, by the way. It's all TEDx style on film, so it's really high quality, and it's really awesome to know. What we also did is a bit similar what you guys will be doing in like 15 minutes. After that infusion of Amification, the Amification infusion, the 250 participants had to go through a workshop, a brainstorm, think about the ecosystem thinking, connecting the dots. That's the best way to learn, and also those results from that workshop are also on Vertical Farming Academy, so check that out. It's a really good website with a lot of information. So after AVF Summit 2016, that's in June, that's more than a year and 3 months ago, AMI team, of course, didn't stop. We kept on brainstorming, we kept on organizing events, putting that idea out there, learning, researching. Megan is going to tell you more about the researching part. But there's one big milestone that really, another milestone that was past June, and it was the, yeah. That's weird. Okay. There was a really beautiful picture of the Brussels workshop. We had in June we had the Brussels workshop, which also was hosted by Thomas Zillner, who's here, and we kind of brought 30 experts from all over Europe together to think about an ecosystem that was already existing but still expanding. It's called the Abattoir Ecosystem. It's a huge refurbishing. I don't know if it's the right name for using for cities, but it's a renewal project of one of the biggest social hotspots in Brussels. It's called the Abattoir, and it's there. 9 buildings are being built there. There's already rebuilt. The first one is already built and it has on the roof a big aquaponics greenhouse. And the cellars, there's a mushroom company that's growing mushrooms on beer waste. Of course, it's beer waste. It's Belgium. And the goal for the Dirty experts was to actually think about how they could build the second building as a vertical farm, the second building of 9, as a vertical farm, expanding on that already existing ecosystem that's there, in a social way, an economical way, but also ecological way. AMI is the ecological part, but they really had to go zoom out of the whole thing, understand Brussels, understand the site, and really make that ecosystem happen. It was a 2 days workshop, and it was way too short. It was really way too short. They had to think about vertical farms in a meta sense, really, and that was really hard for 2 reasons. 2 days not enough, but the second reason is because the AVFami white paper was not yet ready. That was under the lead of Megan. We started researching, doing much more research on each of the industries, and yeah, that's what Megan is going to talk about, and she really made us we made a crown jewel. We kind of made a crown jewel, and that's also thanks to you. So A big warm applause for Megan. Thank you, Bree.
All right, hi everyone. Thanks to Zjef. So yes, I stepped in and became the project group manager for AMI. And when I stepped in, as thinkers in the food industry, we know that there are a lot of issues that we're facing, like food waste. We've tried to make food production fit into a linear model, and that's not how food actually happens in nature. And so the AMI idea is rethinking how we're going to do food production in a way that is more similar to an ecosystem than to a linear model. And they had already done, kind of pitched the idea at the AVF summit, and then did the whole Brussels workshop on it. So we knew that we had an idea that people were really, really excited about, and it's easy to be excited about thinking how to apply a new way of going about normal business. What's harder is how to actually transition that excitement and that thought process into a format that can start putting theory into practice, how to get that conversation spread efficiently across communities of all different types. And so to solve that problem, we decided that we were going to write a white paper. So this is our white paper. It's literally a newborn baby. We just finished putting it together, the last design elements this weekend. So if you are an AVF member, you'll have access to that paper this weekend, and then it'll become publicly available down the road from there. But it will be free. It's just available first to members and then to non-members. So if you're not a member and you want to read the paper, you should become an AVF member. And this paper is built on months of work by a team that is made up mostly of scientists and leaders in the vertical farming industry. Most of us live in different countries. We live in a frustrating number of time zones. So this is, I'm very proud, I think we're all really proud of the way this white paper came out. And because we are all scientists, our goal was to try and make a paper that was based on scientific reports and scientific information and kind of modeled itself after what a scientific report looks like. And we also wanted to make it accessible to leaders in the vertical farming industry so that it used science as a basis, but you could have a conversation about it. You could bring it up at a dinner with your friends and kind of grow off the idea from there. And so now we have this white paper. To transition from thinking about something linear, which is a little bit easier to explain because it's typically how we think, especially new ideas, you have to be able to break it down into steps and be able to explain it to people. We really had to boil the idea of an ecosystem down to its skeleton. And so we chose 4 organisms to talk about: the tilapia, the basil, the oyster mushroom, and the black soldier fly. Tilapia and basil, pretty common in these kinds of systems. Oyster mushroom, kind of a specialty item, also good for breaking down your organic matter and making a new market out of it. Same thing with black soldier flies, and I'll go into a little bit about each of those now. So tilapia, kind of a natural pick for what fish species we're going to look at because they are so common. We also already know through aquaponics work that when a tilapia poops, you can pass that water over the root systems of plants, and then they will absorb the micro and macronutrients out of there, and you'll be able to grow plants off of that. So the thing with growing tilapia as it's done right now, though, is you typically get a pelleted food. It's made specifically for tilapia. It meets a lot of its diet requirements, and that gives you a really good food conversion ratio. So you get the most bang for your buck. When you put in a pellet, you get the maximum amount of marketable product out of that fish, and then whatever they don't use goes into their waste and you use that for your plant production. But when you start thinking about tilapia as part of an ecosystem rather than part of a linear system, the way that you feed them changes. And so rather than putting in a pellet and expecting a marketable product directly from that system, you start thinking about how can I meet the dietary requirements of the tilapia, but grow it in a way that it's being fed things that are more natural, I guess. And so we know that tilapia are omnivores, which means they eat plants and protein. And a tilapia, to get a maximum yield, you want to feed it a diet that consists of 30 to 50% protein. So wouldn't it be great if you were growing something in your system that had about 40% protein body content, which happens to be what a black soldier fly contains when you feed it the right diet. And so now you have a tilapia that's ingesting black soldier flies for protein. You can complement that with an algae, and now you have an omnivore's diet that's coming directly out of your system. The result of this, I guess, is that your tilapia has a lesser food conversion ratio. So instead of being super efficient, taking in a pellet and maximizing what meat comes out of it and then minimizing its output, you have this more complex diet, and so you end up with more nutrients in the water because the tilapia are working harder to digest what you're putting in because it's not made specifically for their system. And then you can grow your basil off of the extra nutrients that are coming through in the water. And we know how this happens, pass over the root system, they absorb it. But we also know that plants are photosynthesizers, so they need some sort of light source in order to be able to grow and produce. And an issue with these light sources is that they release a lot of heat. And so what are you going to do if you have heat at the same time your plants are releasing a lot of humidity out into your air in your system, and they're producing a lot of oxygen? So now you have this hot, humid, oxygen-rich air, and you need to ventilate it somehow. And wouldn't it be great if instead of ventilating it out of your building, you could just redirect it to an organism that loves hot, humid, oxygen-rich air? And now we have mushrooms. So this is a marketable product that you can take from the abiotic outputs, and depending on how your plants are doing, maybe the biotic outputs of your basil. And you're not adding much new energy into your system in order to be able to grow a new item. And so in order to set up this system, and you've been thinking about how to connect all of these things, and you've had a lot of late nights and a lot of early mornings, so you've been drinking a ton of coffee, but because you're responsible members of a food system, you keep your coffee grounds, and you've been trying to figure out how you can compost them. The great thing about mushrooms is they can grow off of coffee grounds. So now you have the abiotic needs for mushroom growth. You also have a biotic medium that you can grow your mushrooms on. I hear there's people doing it on beer waste, so if you're more of a beer drinker to get through stress, there's that option too. And now you have kind of a more unique product than just a fish or plant coming out of your controlled environment agriculture system. And so what do you do about the rest of your organic waste that's coming out of your system and out of your neighborhood, out of your household? You can grow black soldier flies. So similar to mushrooms, they thrive in dark, humid, oxygen-rich environments. They can compost low-quality organic waste. So this can include, it can include anything that typically is categorized as a waste product and a problem for the food systems that we are based on today. And if you get to a point where your black soldier flies are breaking down your compost and you just have so many black soldier flies you don't know what to do, and your tilapia are well fed on a product that produces 30% protein, which fits inside their diet parameters. And now you're like, what do I do with these extra black soldier flies? Well, you can market them as both larvae and adults. And you can powderize them. But if you get into this market, that's like genius on your end of things, because black soldier flies are predicted to grow to a market of $500 million US in the next 5 years. So if you're looking for a unique product to make money off of, that's going to complement your ecosystem, black soldier flies is the way to go. And when you get into that market, you're going to be helping your peers to reduce their need to rely on fish meal and feather meal, which are typically fillers in pelleted fish food. And those markets are really dangerous and have dramatically negative impacts on the global ecosystem. So it's good all around. So once we kind of had a profile for all these organisms, we had to figure out how are we going to start fitting this together in a way that's easy to communicate and easy to understand, even though it's a complex system. There are a lot of challenges in this. Part of the reason why we love this idea is because an ecosystem is not linear, and like I was saying, that makes it extra difficult to explain to people. And so what we have here with these 4 organisms is really just the tip of the iceberg. These are not the only organisms that you can make this kind of system with, and these are not the only applications that you can use for an ecosystem type thinking, but this is just how we decided to present it and share the idea via our white paper. But there are a lot of other conversations that still need to happen for how to make this theory a reality. We have challenges with things like what are going to be the policies and the theories that are going to apply to transitioning from a linear system into an ecosystem. Everything from the organics conversation that's going on right now with controlled growing, through to how do you even initiate something like an AMI ecosystem into your local economy? How do you tell consumers exactly what your product is and why it's so unique? And what are the policies around how you bring in organic waste into your system for things like mushrooms and make it sanitary and agreeable to the market and to the policies surrounding it. Always challenges with engineering and urban farm and urban design. How are you going to retrofit a building to hold an ecosystem? Are there places in the city that are actually more conducive to this kind of building than other places? Are there areas where you can really minimize how much energy is needed in order to make this system work? Because that is the point of making an AMI system and including it as part of the ecosystem of a city rather than forcing it into somewhere where it might not be the best fit. And then, like I said, because we're all scientists, research was a big challenge for us. There was a lot of work going on between all the different science communities for several different countries, but we really do need more work, especially on what are the inputs and outputs of organisms that are being grown in different conditions indoors. What are the nutrient profiles of their waste, the nutrient profiles that maximize their growth. And this is especially true for these newer kinds of organisms that we're trying to include in the system, like mushrooms and black soldier flies. We need all the help that we can get with getting that information. So to sum this all up, in order to take this now from what was a conversation is now a white paper and then put it from theory and paper into practice, we need leaders in the vertical farming community like you guys. We hope that this paper and today and all the different events that we host like this are catalysts for starting this conversation, for getting people excited about the idea and thinking about how to produce food in a way that might be new to the way that you've ever considered how to produce a system before. And we hope that you guys will join us in that process. So, thank you. questions. Yes, Jonas.
You said that you want to supplement the insect or the food for the fish with algae, so half algae, half insects.
Yep.
How do you want to grow the algae, and where does the fertilizer for the algae come from?
Yeah, so that is something that we just didn't have the resources to cover in this report. That would be an example of something that we definitely need more conversation around and we need more research surrounding, but we just didn't have the resources for this white paper. But yeah.
Could you give just like a rough back of the envelope relative area? So say I had 100 square feet, how much would I need for the fish, for the plants, for the insects, for the mushrooms? Like, what's the relative area demands?
I would say that's not the way you should think about it. And the way you should think about it is the first thing is what is available. That's the first question you have to ask if you live in a country where they drink no coffee. There's no way you're gonna be growing oyster mushrooms on coffee. If, like in the Abattoir case of Brussels, there was a huge 4-day market where you have 100,000 people coming in and buying food, and you have, how much? It was 7 tons of organic waste per week. Then you don't grow, that's kitchen waste, vegetable waste. You don't grow mushrooms by factory, because that's how you revalue that waste. So you don't make that, you think about what's available and then you start thinking on what to grow.
But
yeah.
And in the white paper, we do like a little breakdown of basic requirements for each level for a system based on these organisms. And there will be like an outline of like a density for how many fish can fit per meter cubed or liter of water. So we do talk about it in the paper. But again, yeah, the first thought in this kind of thinking should be, right, what do I have available, and then what will work in that space.
Is there any economic feasibility study on how to scale up?
Well, I don't know of any economic models yet that reflect an ecosystem style of growing things. It was something that we really struggled with writing this paper, was just kind of the lack of resources of how to base this conversation in reality. And that's what we're hoping to spark with the white paper, is these conversations that the more people we talk to about it, the different resources everybody has, and then maybe one day someone will write that paper, and then the next time that we write an updated version of this, we'll have that to reference and we can have an answer to those questions.
Well, to add to that too, about the Brussels workshop, it was too short, so some of the people decided they wanted to work further on the case. So they're actually working on finishing a kind of case white paper about that case. So they want to build a business out of using that organic waste, and they want to build a vertical farm. So and the way they do that is by asking people who are already doing it. Like in the insect industry, there are already a couple of companies all over the world. In Belgium, we have, for example, a big black soldier fly company. For mushroom companies, there's many small mushroom companies that use organic waste. You have them in the US too, I know for sure. And it's, using what's already available of people doing it and putting that together, getting the numbers there, what is economically viable. So it's a process of putting things together, and it's not easy, but we're trying step by step, and that's why we need your help, right?
You're creating a very simple ecosystem, which ends up having its own issues after having too much of the same exact thing.
Right.
What are the cross impacts that end up happening? What are the issues you're anticipating having such a limited notion?
Right, okay, so you can have issues with like unhealthy fish if you're feeding them. I mean, algae and black soldier flies is a great solution compared to pellets, but compared to what a tilapia might eat in nature, it's not the greatest solution because they're getting a varied diet, and that's not what they would be getting if you're growing algae and you're growing black soldier flies. And then you have like the diminishment of nutrients as the cycle goes through and goes through and goes through. So the idea is that this is a starting point. we don't have like solid answers for what the macro and micronutrient fluctuations would be after like several cycles. We understand that this is a really simple ecosystem, using the term lightly, and that there are a lot of things that can change when you actually put this into practice. The goal is to get to that point. Right now, we just went from like, wouldn't it be great if one day we lived in a world where we could grow ecosystems in buildings, and now we have a paper about it. And now we're getting these questions, and we're hoping that these questions will push to answer those, to get you those answers. So, yeah, we just don't have the answers.
Well, I guess it's like a companion question then, like what other species of fungi or composters could be used in a system that, you know, uses the same framework but maybe produces different crops?
Well, there's like red wigglers you can use as insects, and crickets is like a huge market. So in terms of insects, there are like a few different options. There's tons of different kinds of mushrooms you can grow.
Yeah, I did an interview with the guy from the Belgian company, Black Soldierfly company, and he said to me like Black Soldierfly is the most popular one because it's the known one, but there's billions types of insects, and for every type of organic waste, there is kind of a mushroom or an insect that can be used. So we're really at the beginning of what's possible, what to grow, what to use, and that's why we need to start thinking, researching. You know, if you go to the Amazon forest, still every day they find new species, right? It's the same with if we want to build our ecosystems.
Black soldierflies. The clear benefits of black soldierflies.
Well, they can compost low quality organic waste. So, and they turn it into protein. And like those two aspects of them, that's massive, that you can take your kitchen compost and change it into a protein source for another part of your ecosystem. That's incredible. And then they're also marketable as larvae and as adults, so you kind of have two different markets you can tap into, or two parallel, I guess, markets that you can tap into. So.
You can also use them for chitin, which is used in the pharmaceutical industry. So there's many, and they also hold a lot of lipids, so you can really split that one up.
One of the problems that you face when you have aquaponic system and you want to use organic waste is that you really need to know where organic waste is coming from. So if you have pesticides in your organic waste, it will stay in the system, will end up in the plants. So do you know if you feed insects, like do you eliminate those pesticides somehow, or do you have any idea where to get like perfectly clean organic waste from?
Same answer.
I mean,
we need more research on that.
Yeah. Yeah.
I didn't catch the question.
Would black soldier flies compete with the other insects in the system? But we haven't thought about. We're at the most simple, basic level right now. So we have one. We did our example with one insect in the system. So it could be an issue depending on what you pick in the future, but we're not there yet.
And we're also working in controlled environments. So the insects are in a controlled environment. You control what's going in, what's going out. There should not be any other insect in there. Same with the mushrooms. You don't put one big biodome. It's really small cells, like a plant factory. You know what goes in, what goes out. You have like an insect module. You have to think in modules and see where every research flow can go. And that's what you guys have to do, because what time is it now? Because you have to start thinking in ecosystems.
Yeah. So.
Time for that.
Yeah. So, sorry to cut the questions off,
you can ask more questions. We'll be around. So.
Yeah, and we're gonna do a breakout session. So, if everyone could break up into 6 groups of 5, there are name tags and index cards, and what we'd really love to see come out of this conversation and all these questions is each of you designing kind of your own AMI system. It would be great if you could design it with New York City as your backbone, but how it works for you or your team is great, because we need every conversation about it right now. So if you could break yourselves up into these groups, we'll give you about half an hour to discuss your AMI system. You can use some of the numbers that we've provided if you're interested. We have New York City's sewer system if you want to take on that aspect of it. You can also think about things like food waste that comes out of the schools in New York, and the coffee waste that's going to come out of all these new blue bottles now that Nestle bought them. So some answers that we're looking for when you do come up are how to explain your ecosystem, what kind of issues does it address in, hopefully in the New York City setting, but really any urban setting. What are the products that you're expecting to produce? What are going to be the challenges of your system? And what are potential solutions to some of those challenges that you could answer when people ask you a million questions about them. So, yeah, you guys could break yourselves up. We have half an hour, and around 11:20, we'll meet back up again, and then you can send up a representative from each team.